Hello, my name is Sam Cheney. I'm a Senior Application Engineer with Geomagic, and today I want to welcome you to the first episode of our Inspection Insights series. Now, this is going to be specifically focused on the application Geomagic ControlX. We're going to go through a few different customer applications, give you tips and tricks, and if you're a fan of our other content and maybe you use reverse engineering software, Geomagic DesignX, it's going to be a similar format. Instead of just having Greg George, my manager, present the whole thing, this should be a collaborative effort from the rest of the application teams as well. We have a few different applications lined up over the next month or so, and today what we're going to focus on is going to be a consumer product application, specifically a stamped bracket. Now, we're going to cover lots of different applications. This is just one of them. I believe we actually covered this in the RE lab. So if you want to learn how to actually model this from scan data, be sure to check that out. But today we're going to be bringing that same CAD model that we designed in DesignX into ControlX for the sole application of inspecting it, checking that it is to spec or analyzing its deviations. So a little bit different in terms of the end result, whereas with DesignX you're trying to go from scan to CAD. With ControlX we're trying to go from CAD and scan and analyze the scan. So we are, our CAD is going to be the real world. The CAD is going to be the kind of like quote unquote gold standard. It's what it should be. And the scan is the real world equivalent that we have actually manufactured. And as you can see here, we've got a few different images on the screen. The stamped bracket, I think this is used to hold like appliances, like a dishwasher or an oven in place while it's in your kitchen. And on the right, we have the CAD on the bottom. The blue image is the scan data. We all should be pretty familiar with that if you're a fan of the RE lab. And then at the top we have our color map. Now, this is just one comparison that we can actually do inside ControlX, and we're going to get more into all of the other things that we can do both on this webinar and throughout the series. Now, how does a typical inspection workflow look? Well, we have our import, the first step. So we import our CAD data, import our scan data, and we actually don't have to always import CAD data. We pretty much always should be importing scan data because that's really the basis of what we're trying to use to inspect and measure. But if we don't have CAD data, there are applications and instances where you can do a scan to scan application, or even just a scan to nothing. If you don't have CAD but you still need to inspect it, you can create reference geometry on that scan data and then analyze it based on basically a scan to drawing inspection. Now again, that's probably something that we'll cover in a later episode, and if you do also, before I get too far into this, if you have something that you'd like to see, a tool that you'd like to have one of these inspection insights cover, please don't hesitate to reach out to one of us or leave a comment on our YouTube video, and we'd be happy to incorporate that feedback. At the end of the day, this whole series is meant to strengthen your own knowledge in this software and provide you with insights, tips, and tricks to help you get the most out of this pretty cool software. Okay, so we import, and we are going to be following this typical inspection workflow today. We're not going to be deviating, especially for the first one in the series. We're going to keep it simple, at least for the moment. So we're going to import the CAD and scan data. We're going to align the models. Now, alignment's really important. I could do a whole, hour webinar about just alignments, but I think I'm going to talk a little bit about it, not get too far in the weeds, and then we're going to start our inspection. And we'll do some 3D comparisons, maybe some 2D compares, and actually take some measurements as if we were setting up this inspection for the first time. Once we're finished with that, we'll then export a report, and that should be it for the webinar. Now, A quick note before I exit the presentation and start turning it into the software portion of this conversation. Geomagic ControlX actually has 3 plans, and if you weren't aware of that, you are now. Check out this table below. There is ControlX Essentials, which is really the bare bones tool set for everything you need for a basic inspection. Really cheap and cheerful, good for pretty much any application, as long as there's not anything crazy that you need to do. As you can see there, you can import, edit, align, extract, compare, yada, yada, yada. You also have the full suite of reporting tools, so you can create a report, export it as a PDF, edit it however you'd like, and you can also do repeatable inspection routines. However, with Essentials, you cannot scan directly into the software, so you don't get any of that live capture tab. For that, you would need Essentials Connect. This is really good for anybody who's using a portable scanner that needs some kind of software to actually scan directly into. As you might be aware, again, with the RE Lab, we can scan directly into the software, but you just need to upgrade from Essentials to Essentials Connect. Along with that, you also have portable metrology device. So if you have not only a handheld, like an ARM-based scanner, that is also really useful for Essentials Connect. Now, the big difference between Essentials Connect, and then the top of the line version, ControlX Professional, is you do get quite a lot more in terms of automation and more advanced tools. So ControlX Professional is going to be the software I'll be using today. Although I don't think I'll be using much of the surface defect inspection or the automated inspection routines. And then obviously we have specific tools inside Professional for things like aerofoils, and one of my favorite tools is the batch inspection, and you also have scripting if you're doing a lot of high volume inspection. ControlX Professional is really the one that you need to look at. But anyway, enough about that. If you have any questions about any of these plans, or you want help deciding, this is exactly what I do for a living. So please reach out to either myself or somebody else on the Geomagic team, and we'd be happy to have a conversation with you. Okay, so since this is the first in the series, I want to take a quick second to talk to you about this interface. We're going to be seeing it a lot over the next couple of weeks, months. This is Geomagic ControlX. At the top, we have our toolbar, or toolbars, I should say. And this is based off of, or inspired by, like a CAD system. So if you've learned SolidWorks or Inventor or any of those major CAD packages, you should feel right at home. With the Home tab, really, the Home and the Quick Start, you could pretty much do a full inspection without leaving these toolbars, because it's a very left to right workflow. You import or you live capture, you do your alignments, then you do your comparisons, do some dimensions, generate report, and you're done. And that's pretty much all we're going to be doing in this inspection instance. However, we do have tools for doing GD&T or live capturing, or editing the CAD model or the measured data. On the left-hand side, we have our model manager. This is where we're going to, as you can see, it's kind of already populated, but these are all these different buckets. So I like to think of them as buckets, and then you can turn these buckets on and off with these eye icons. So if I want to turn my CAD data on, I press this eye icon here, and you can see there in the middle, in our main display, we have our CAD that's popped up. Now you also have the measured data. This is going to be our scan data. You can see there we have our scan data now shown as well. These buckets will populate as we complete more and add more items and complete this inspection report. On the right, we have our display and our properties tab. We can actually add a few more. We can customize this ribbon or add any other display or properties, etc. I really like the display. Keeping the display one in case I want to do a view clip or change the shading in my display. At the bottom, we have our table view. This is blank right now, so I'm going to keep it out of the way, but when we get to actually doing dimensions, this will start populating. We can use it to look at what measured values are. Okay, so we've got our scan and our CAD. Now, typically with most inspections, you don't really want to edit the CAD all that much. You want to keep it raw. You don't really want to change it, because if there's a big gaping hole somewhere, while we can come to the measured tab and fill holes, for example, do we necessarily want to put computationally generated data somewhere that we have missing data on the real part? Maybe the part's actually damaged in this area, as again, assuming that this is the area that needs to be filled. Do we want to fill that? Is it small enough that it won't affect the inspection report? Or maybe, we should just go back and rescan the part and knit that new scan into the existing scan. That's always what I'd recommend. But there are instances where, there might be a small hole and you just want to fill it. And that's okay. For something like this is clearly probably not anything that actually exists on the part. Again, if you had the physical part sitting by you, you could check and see, is this something, is it a bit of somebody's lunch left over that's just stuck to the part, or is it actually something that we need to be concerned about? Just to show you some of the tools, we can use our paintbrush selection tool. We can select around this Rice Krispie or whatever it is, and hit delete. And you can see there, we've deleted all the way around, and I can actually use this flood selection, which is just going to select all of the thing that I want, and I'm going to delete that. And you can see now that we've got a hole in our mesh, it's orange. This is actually the back surface, so we're looking inside the part. So the part essentially is contrasting colors, right? It's blue on the outside, orange on the inside. So you can see we're seeing into the part over here. And if I select none, if I select some of this orange, see this is the face that we're selecting. So we're seeing into the part. It's an obvious hole. Now I can fill this hole, and I can fill it either flat or based on curvature. And given the nature, it's right on a fillet area, I can just fill it flat. So let me just click that, hit the check mark, and there we go. We have removed that piece of dirt from the part, and we can continue. Again, in most inspection routines, I'm not going to be doing a lot of editing. I might do a bit of decimating, which is essentially reducing the triangle size. Let's see, how many triangles or polygons do we have? Come to my properties. We have 1.6 million triangles. Is that too many? No, it's probably right about the right number. If I wanted to, though, I could always decimate it. But again, I'm pretty happy with what we've got, so I'm just going to leave it as is. Sometimes another thing that I do, just to make sure that the health of this scan data is good, and this is really useful, especially if you are scanning it directly into the software, is to run this healing wizard, and it's going to quickly identify any small clusters, crossing polyfaces, non-manifold edges, etc., and it's going to just take care of them for you. You can see there's one selected right there that we can see, and that's a small cluster because they're all color-coded. So it's going to run the healing wizard. There we go. We've got a nice clean mesh. You can see boundary count 0. So what does that mean? It basically means we have a watertight mesh, so there's no holes inside this mesh. So again, another good indicator of the health of this scan. Okay, I'm happy with that. Now what I need to do is align this scan data to this CAD data. Now you can see in my alignments, I already have one, because when the two came in, they were already pretty closely aligned. So I just added this transform alignment. So if I just delete this, you can see this is the without any kind of alignment, it's actually been modeled in the same coordinate system. So that's nice, but we can't just do this inspection without any kind of alignments. So what are we going to do? Well, we're going to do an alignment. Now in the home tab or the quick start tab, you do have different alignments. The home, you have a few more. We always, and I'm I'm going to be repeating this a lot. We always start with an initial alignment. Now, it can be quick, it can be precise. For 90% of the applications I come across, quick works just fine. And this is basically just like a rough position. You can see it didn't really change all that much, but we've got our initial alignment. And now what we need to do is do our like more formal alignment, the alignment that we're going to use for the rest of the inspection routine. Now you can do a best fit if you have datums on your, if you have a drawing with a print. You can do, the 3-2-1 or a datum alignment. For today's application, a best fit is going to be just fine. And just to talk a little bit about best fit, you can see here we have a sampling ratio. That's how much data you're going to be, a minimum data you're going to be trying to match. How many iterations you're going to be doing. The higher you put this number, oops, that's the lower. The higher you put this number, the longer it's going to take to align. Shouldn't take too much longer, from between 20 and 30, but just so you know, that's something that can affect it. And then we have our max average deviation. We can leave it on auto, or we can press this icon here, which is going to actually estimate it for us. So you can see there, it's estimated it. If there is some particularly noisy areas or damaged areas, or areas that you just, the part is out in a particular orientation, you can say use only reliable measurement data, or use selected data only. And this is going to then have you select that data, and you select it based on the CAD. So, if I know this surface up here is wrong, or is not critical to my alignment, and this surface is, well, I just click on, these sections, and it's going to only use whatever I've selected to influence this best fit alignment. Now I want to use all of it, so I'm just going to, unclick that, but I just wanted to talk about it. Here, let's turn the mesh back on. We hit our check mark, okay, and now we're going to do a best fit. And you may have seen a little bit of a jump. There was a little bit of a change over here that I managed to capture, but it's a pretty good alignment as is. So, you didn't see too much of a visual difference, but you can see there we have our best fit alignment. Okay, we've done our alignment. What's next? Well, I always like to start off all of my inspection reports with a 3D comparison. And really, I could do a whole webinar on this 3D compare tool. I'm going to put a pin in that and consider it for another day. So I just hit to the next stage. And you can see here, we've got our color map. Now, we have our maximum deviation, our color bar on the side. So we can double click this. And if we wanted to change it to 2 millimeters, it would help if I had my num lock on. There we go. You can see there, it increases the maximum area of the range. This range here, 0.1, is essentially our tolerance zone. So anywhere that's green, it's within tolerance, and it falls outside of everything else. You can see here, it's plus or minus 0.1. Now I'm happy with that. In this menu, after you've gone from 3D compare options, next you've got your preview. Anywhere that you click on the mesh, it's going to add an annotation point. And this is really useful when you're trying to, analyze certain areas. You can, anywhere you click, and it's going to add deviation callouts. Now these deviation callouts are kind of fixed wherever you put them, unless you come up to this menu up here, and you can see it says automatic. If you change it to snapped, you then have full flexibility to move these callouts to wherever you want them. I'm just going to scatter them around. Once I've got them happy, they'll stay there. And if I want to change how these deviations look, or these callouts look, I can right click, change my preset, and I have basic. Or if I, one that's really dramatic is the detailed, and it's going to give you the X, the Y, and the Z position, both reference measured, and then where it falls, the deviation, the tolerance. It's going to give you a lot of information. Now this is useful if you are a very visual person who wants to look at pictures and also read those annotations. I know that anywhere that I click, it's going to give me these 3D comparison points in a list, and it's going to display it in my report in a table later. So I like to keep my deviation, or I like to keep most of my presets set to basic, or even just simple if you just want a number. That can be quite pleasing on the eye as well. Once you hit the check mark, we then have our 3D comparison. I'm going to stick in this view because I really like how it looks. If I press my 3D compare, you can see down at the bottom, whoops, that was a double click. If we press it once, you can see here, this is our view. Now if I rotate it around, if I wanted to change this view, I would press this. And if I press this, it's a reassign viewpoint. You can see there, it matches my view. Now, if I rotate it around, and I want to get back to this view because I was like, this is a great view. If I press this one, apply viewpoint, it's going to change the view in this tab to take me exactly back to where I want to go. Okay, now I'm going to just reassign viewpoint, and I'm going to turn off these annotations. And maybe I want a lot of visualization in this of this color map on my report. So maybe I want to see it from the back face as well. I'll get it exactly rotated how I want. That looks good enough. Yeah, that looks good. It's kind of a bit skew-if, but that's fine. It's my inspection report, not yours. I'm happy with that. Once I press this, add viewpoint, you can see down at the bottom, we have custom views. So we now have another view that's going to be in our report. And I can change the name of this as well to, bottom face. And there we go. We've added a custom view. Okay, so we have one element of our inspection. We've got our 3D compare. I can just turn that off again. Now we can do, a 2D comparison. We can, with the 2D compare, it works very similarly to the 3D, except we have to give it a plane first. Now we can offset, rotate along the curve. I'm going to select the base plane, down. Yeah, I'm pretty happy with that. Hit the next icon, and you can see there we've got our color map in 2D. Now this is kind of hard to see without zooming all the way in. So one trick I like to use is change this whisker multiplier just by a little bit. Don't get too aggressive though, because if I turn it all the way up to 100, it gets real crazy. So you want to I like to keep it somewhere between 0 and 20 is normally where I like to keep it. And it's pretty dense, so I also like to reduce the display ratio down just a little bit, just so it's a little bit easier to see. Again, anywhere I click, I'm going to add a preset, add a annotation. Once I hit the check mark, I now have a 2D comparison that I can use in my report. Okay, we're done with the comparison tools. Now let's move on to the real meat and potatoes of this inspection report, and that is going to be the dimensions. So we can start with our smart dimension tool. Maybe we want to measure the angle between this plane and this one. See there, it's blue right now because I haven't hit the check mark. Once I hit the check mark, it'll give me green if it's in tolerance, yellow if it's kind of almost out of tolerance, and red if it's out of tolerance. Set my tolerance, hit the check mark, and there we go. You can see it's red, so that's out of tolerance. You can see the measured value is 92, and our tolerance is only 0.5, so it is out of tolerance. And that makes sense. If I turn my scan data back on, you can see this is high in both planes, so it's probably it's just a little bit out of, it wasn't bent all the way, it wasn't stamped fully. So we could kind of tell that visually from the color map and from just the overlay, but actually putting numbers to it is also very useful. Now I can do my linear dimension. So if I want to do like a center to center of these hole positions, I can zoom in, grab center to center, move it up, hit the check mark. There we go. I've done some more. Let's do a radial dimension. Let's grab the radius of this cylinder here. And this is all all of the reference dimensions are being pulled straight from the CAD model. So I don't have to necessarily come in and tell it what the right answer is. Now maybe the reference is 24.025. Maybe the drawing is, doesn't match the CAD, and the drawing says it needs to be 24. Well, I can type in 24 and then essentially overwritten what the CAD model is. So again, it's control. We call it control. It's for a reason. You have full control over all of this kind of stuff. If you want to, you can keep going with these dimensions, and you can see they're added as a group. If you have a different view, you can add another group. Maybe we want a view just from this side, or actually let's do a view from the top of this plane. We'll do from this to this, and we'll do from zoom in. Sometimes it's hard to grab that, so you might have to rotate over to this side. Do from this plane surface here to this plane. Got to hover over it, zoom in a little bit more. There we go. And let's do from here to here. I'm just kind of making this inspection report as I go along. Obviously, you guys will probably have drawings that you need to adhere to, so you just make sure it matches the drawing. Grab our next group. Now, I don't want this to look like this, so I'm going to hit reassign viewpoint. Again, I might need to just zoom in, reassign viewpoint. Let's keep going. Let's really make sure that we can see this on our report. Okay, lovely. That looks much better. Okay, so I'm happy with the level of inspection report that I've made. You can keep adding these smart dimensions. You can add GD&T and all of that, and we'll cover that in a different application. I'm just kind of taking you through a very basic workflow. We can come to our Home tab and hit Generate Report. Now we get our report generation template. This is where we can add a title. Give it a title, give it an author, add whatever you'd like, and then we have our list here of all of the different things that are going to be listed in our inspection report. Now I don't necessarily need my initial alignment, so I press this button here to remove it. And remember that custom view of the color map that we created in the beginning. Well, we labeled it bottom face, and I actually want this to be displayed after the color map, the 3D compare. So I'm going to just press this to move it up, and you can see it moves all the way up to exactly where I want it. And then we have we know exactly what's going to be reported on in what order. So I'm happy with that. Hit generate and give it a second to process. Now, if you have your own report template, again, that's probably something else we'll cover in one of these sessions, is how to edit and create your own custom report templates. You don't necessarily have to have our logo here. You can always come in and add your own logo, set your own template, make it look exactly how you want. Scrolling down, we have our reference data, aka our CAD, measured data, aka our scan, that best fit alignment that we've done, and we've also got our minimum, maximum values, the standard deviation, and the variance, and it's also displayed in a histogram there. Now we move into the real part of the inspection routine, which is our 3D comparison. Again, we've got all of those annotations that we added, and on the right here we have our statistical data that we can use as well. If we want to move one of these or change the size of it, we can. I'm happy with where it is. And then remember how I said you can adjust these annotations to be really detailed, but I don't like to do that because we have a table, and this is that table that goes with all of those 3D comparison points. Now we have that custom screenshot that we added and our 2D comparison as well. We even have a slice on the CAD as to where this 2D comparison was taken, so we know exactly in relation to how high in the part we're actually taking this cross section. Again, annotation in table form, and now we have the actual first group of dimensions that we created. So we've got, you know, two a radial dimension, a linear dimension, and an angle. Scroll down, angle, linear, radial, all displayed there. Now this part clearly fails, is not in tolerance. Pretty much everything is out of tolerance, and that's okay. We're you know, we need to then go back to our stamping die and readjust and use the dimensions that we get in here to influence how we're going to improve the production process so we get parts that are right first time. Our second group here, and then our table view. Once we're happy, you know, we've reviewed our inspection report, we want to save this out and, you know, make a new inspection report or send this to somebody else down, you know, in the next office over. We can come to default, and then we can save this as a PDF. So I can save this as, you know, stamped bracket, and then we have a PDF that's generated. You don't have to just save it as a PDF. You can save it as a PowerPoint or an Excel file, whatever you'd like. Yeah. So that is that for today's inspection insights. Hopefully you learned a lot. We're kind of easing into it with this first one. But again, if you have anything that you'd like specifically covered, any applications, please let me know. I'd be happy to, you know, incorporate that into what's coming. So thank you so much. Have a great day. Goodbye.